Hey everybody, this is Nick, and today we'll be finishing up the missile defense game that we created in class. So I've got my code here, and on this particular computer I'll be working in Flash CC, which is not the same as Flash CS6. So I've created a different version of my FLA file, just in case I ever want to go back and edit my CS6 version. If you have CC, you might want to do the same, but otherwise this might not apply to you. So I've got the file open here, and if you run it, this is what we had in class. You click play, and then you have to click on the stage again, and then you can use the left and right buttons on the keyboard to rotate the launcher. We spawn enemies, they slide down the screen, and then they disappear when they get to the bottom. Obviously our game is not done yet, so let's dive right in and start making some changes to it. After opening the FLA file, I probably want to open up all of the ActionScript files along with it. So just navigate to those. And there we go. I'll be making my font size a little bit larger for you. Where is it? Right here. Cool. All right, well, one of the first things I want to do is I want to make it so that when you run the game and you click the play button, you don't have to click on the stage again in order to start rotating the launcher. So there's a little bit of a bug or an annoying side effect of clicking buttons in Flash is that it steals focus away from the stage. And when you do that, you can't properly detect keyboard input. So I'm going to go into the state play class, and in its constructor, I'm just going to say stage.focus equals this. So actually what I'm doing is I'm telling the stage to set the main focus of the program to this object, which is the state play object. The state play object, since it's on the stage, it will be able to capture these keyboard events that are being listened to by the stage itself. The reason why I have to do this, I believe, is because when we click on the button, our focus switches to the button, and then once we go forward a frame, the button is removed from Flash. So the focus is kind of off in limbo. But if we save this file and run it, clicking play, we should now be able to rotate our launcher and not have any issues with that. And that's a little nicer. The next thing I want to do is I want to change how quickly the enemies spawn. Right now they are spawning every frame, and since Flash is running at 24 frames per second, we are generating 24 enemies per second. This is probably too many for the player to keep up with, and certainly looks like a mess on the screen. So I'm going to go down in my code to where they're spawning, and in the update function, which is the function that's running 24 times a second, I'm calling the makeEnemy function that I created. The makeEnemy function creates a new enemy object, stores it in variable E, and then adds that object to the display tree, and then pushes it into our enemies array. What I want to do, obviously, is probably not generate an enemy every single frame. And there are a couple different ways to do this. We can generate a random number. So I'll say var n is a number, and it's going to equal math.random. Math.random gives us a number between 0 and 1. So what we could do is say if n is greater than 0.5, let's generate an enemy. Now, if we're constantly doing this calculation 24 times a second, on average, n should be greater than 0.5 about half the time. So this should give us actually, on average, 12 enemies per second instead of 24. And if we run it and hit play, I think you'll agree that there are fewer enemies on the screen here. But this is still completely random. I mean, there's no guarantee that we'll get 12 a second. We may occasionally get 24 enemies a second still, although the chances of that happening are very low. So we could continue to reduce the odds here. So for example, if I said if n is greater than 0.75, that actually happens 25% of the time. Another way of writing this would be to say if n is less than 0.25, and now it's very clear. If n is less than 0.25, 25% of the time. So this means at 24 frames per second, 1/4 of 24 is 6, so we should be generating 6 enemies per second. And I could, if I wanted to, I could keep reducing that number, but there's another way for us to reduce how many enemies we're spawning. We could actually start counting how many frames have gone by. And for example, we could say after 10 frames have gone by, let's generate a new enemy. And this method works very well. So first thing we need to do is we need to realize that we have to store how many frames have gone by. If we want to keep track of that information, we need a variable. The variable should not exist inside the function because it shouldn't be declared inside of the function. Variable n here is declared inside of the function, and it will cease to exist when the function's done running. So next time I call the function, I won't be able to access what n was the previous time. So therefore, our counter variable that counts how many frames have gone by, it needs to be a property out in the class. I like to declare all of my properties up here at the top of the class. So I will come up here, create a new variable, and I'll call it spawn delay. And again, this is just going to be counting how many frames have gone by. So I could set this spawn delay, by the way, it would be an integer if we're counting frames. I could set it to 0, and then every update I could maybe add to spawn delay. Now, since this is specifically used for creating enemies, I'm actually going to move that into my make enemy function and just kind of keep the update method nice and clean. So now instead of generating n, I will say, if spawn delay is greater than 10, and then we'll create an enemy. So, what happens is the first time, all right, we go into the update function, spawn delay is 0, then we'll call make enemy. It's going to increase it to 1. 1 is not greater than 10, so we don't make an enemy. The next time make enemy is called, we're going to increase it to 2. 2 is not greater than 10, so we don't create a new enemy. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Once it's 11, we will spawn a new enemy. And then the next frame after that, it'll become 12, and so it'll spawn an enemy again. So what we need to do is when we spawn a new enemy, we need to set our spawn delay. We have to reset it back to 0. So now we're in a situation where every 10 frames we'll create a new enemy, which actually averages out to 2.4 enemies per second. So if we run this, that's better. We could continue to reduce it by increasing the number of frames that we want to wait. My preference here is to actually flip this around. I like to actually decrease spawn delay every frame. And when I spawn a new enemy, I like to set it to a large number. So what I'm doing here is I'm saying when I create a new enemy, set spawn delay to 30. And then it's going to count down. It's going to go 29, 28, 27, 26. And then I say down here, if spawn delay is less than or equal to 0, then spawn a new enemy. Now, the reason why this is really great is because I can now turn 30 here into a random number if I want a little bit of randomness. Because if I don't, then it becomes very, very regular. Exactly 30 frames or exactly 50 frames, we spawn a new enemy. But what I could do is I could say, I want to spawn a new enemy, and I'm going to use math.random, and let's say I wanted to generate a new enemy between every 30 and 60 frames. Okay, well 60 minus 30 is 30, so we have a range of 30, and the minimum number in that range is 30, so I'm going to add another 30 to that. So now this line of code will make it so that every time we spawn an enemy, we set up a timer so that we don't spawn another enemy for another 30 to 60 frames. It depends on what number is generated here. So if we save this and run it, we'll get something that is both random and yet somewhat predictable. This is the best of both worlds. Now, what I've done, like I mentioned earlier, is I've taken all of the logic that I use to create enemies and I put it in a separate function. That's called refactoring. I want to do the same thing here. All of the lines that I have highlighted right now in the update function, these are the lines of code that I use to update the enemies. I'm going to take all of these lines of code and move them into a function called update enemies. And the only thing that function is going to do is, well, it's right in its name, it updates enemies. So I'm going to highlight all of it, Control X to cut, and then I'll just say function update enemies, and the function returns void, and then Control V to paste everything back in. This is going to make my code easier to understand, especially, for example, if you look up here in update, it becomes very clear what the update function is doing. First thing we do is we make an enemy, then we're going to update the player, and then we're going to update the enemies. And that's it. And then if I'm interested in, okay, what is the logic for actually updating enemies? Well, then I know that I need to go look at this function down here. So it's really good to make sure you're looking for opportunities to refactor and optimize your code for readability and understanding. I think the next appropriate thing for us to do would be to make it so that our game shoots bullets. So what we want to do is create a missile class or a bullet class. If I go into my FLA file and I find the library, you'll notice that I have some artwork for a missile object. I want to attach this artwork to a missile class so that I can generate new instances of this in my code. So I'm going to right click and go to Properties, choose Advanced, and Export for ActionScript. I want to name my class Missile with a capital M. And I'm going to say OK. I'll say OK again, and then I'll right click on my object here and choose Edit Class. If you have Flash asking you which program you want to edit the class file in, you probably want to edit it in Flash Professional. You probably don't want to take the time to learn an entirely separate program called Flash Builder. So make sure Flash Professional is chosen and click Don't Show Again and OK. Now before we start writing any code, just go ahead and save this file, Control S, and save it in the same directory as your FLA file. And make sure its file name matches its class name, Missile with a capital M. Now missiles need to move across the screen, so they're going to have a speed X and a speed Y, and we're going to use those values to adjust the missile's X and Y position, which it inherits from MovieClip. But I don't want to have to rewrite, the speed X and speed Y code that I've already written in the sprite class. This is kind of the generic logic for setting up a speed and then updating an object so that its position is affected by its speed. So I'm going to actually have the missile class inherit all of this. So instead of having the missile class be a subclass of the MovieClip class, I'm going to say that it is a subclass of my sprite class. There we go. In the missile class's constructor, we probably want to set up its starting speed. This is a little bit difficult to do because we may know that we want the missile to move at, let's say, 20 pixels per update. But how do we actually find the speed x and speed y components of that speed? And the answer is we need to use some trigonometry. What we do know is we know the angle that the launcher is facing. So if we get that angle, we can then use some simple trigonometry, cosine and sine, to figure out the actual speed x and speed y that we want to use. So when we create a new missile object, not only do we have to know the angle of the launcher, but we also want to know its position. So whenever we create a new missile, we need to know an x value, which I'll actually make capital X. And the reason why I'm making it capital X is that so that we don't accidentally mistake it for the missile's inherited x property. So x colon number, y colon number, and degrees colon number. And I'm naming this parameter degrees so that we know not only is it an angle, but we know that it is in degrees. And that's going to be important. Well, what we probably want to do is have this object start by setting its x and y position equal to the x and y properties or parameters that are passed into this function. So we could say x equals capital X and y equals capital Y. Now from here, let's go ahead and create a variable to store what we want our the magnitude of our speed to be. I'm going to call that speed. And let's make that 20 for actually 20 pixels per update here. And then what we want to find is we want to find, like I mentioned earlier, the speed x and the speed y. And just as a reminder, these are, defined in the sprite class, speed x and speed y. And as I mentioned earlier, our missile is a sprite, so it has those properties. So if you don't remember trigonometry, there is some relationships between the angles of a right triangle and their sides, and you should probably look those up. And a short rule of thumb to remember is SOHCAHTOA. The sine of the angle equals the opposite over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse, and the tangent of the angle is the opposite over the adjacent. Now, if you were to actually draw out a right triangle, you could actually figure out that speed x will represent the bottom edge of the triangle, and the speed y would represent the vertical component, so either the right or the left edge of the triangle. What it comes out to, though, is the speed x is adjacent to the angle. And if you do a little bit of algebra here, you would realize that speed x is equal to the cosine of the angle, which I'll write as degrees, times the hypotenuse of the triangle. Now the hypotenuse of the triangle is actually represented by the magnitude of the speed that we want, which would be, it would be speed. Now speed y is found the same way, so you could copy and paste, but speed y, apparently I'm having some keyboard trouble here, speed y is the sine of the angle times the magnitude. Now, this theoretically works. However, the cosine and sine functions expect your angle to be in radians, not degrees. A single radian is about 57 degrees. So what we need to do is we need to convert these degrees into radians. And again, if you've done any trig before, you may remember that in order to convert degrees into radians, you first have to divide degrees by 180 and then multiply by pi. And that's because the number of radians in a circle is 2 pi. And that's actually telling us, therefore, the ratio of radians to degrees is 2 pi radians for every 360 degrees. If we divide both sides of that equation by 2, then you know that pi radians equals 180 degrees. And there's our ratio for that relationship. So we say var radians is a number, and it's going to equal our degrees number times math.pi divided by 180. Now what we want to do is we want to make sure we pass in radians into these two functions. So I just copied and pasted those in there. Okay, this should work pretty well. Now I'm going to save this file, and what we want to do is we want to go update the game to spawn the missiles and see whether or not this logic works. So I'm going to go back out to my state play class, and we're going to think about when do we want to actually spawn the enemies. Well, we'll be wanting to spawn the enemies when we press down on the 32 key on the keyboard. That's the space bar. So we could write all of the code to spawn enemies here, but I may just end up refactoring that code anyway. So what I'm going to do is call a function that I haven't written yet, and that function will be called spawn enemy. And then let's just go ahead and write that function. So I'll scroll down, pick a place for it after another function. Function spawn enemy. And there we go. Now, as we mentioned before, we need to know the angle that the, not spawn enemy, spawn missile. There we go. We need to know the angle that that missile will be moving in, and we need to know its starting X and Y position. We need to access the launcher to get both pieces of information. And luckily, the state play object contains a launcher object inside of it, and that launcher object is named player. So let's come down here, and what we're going to do is say var m is a new missile. And if you look right here, this little syntax hinting says we need an X, a Y, and a degrees. So let's spawn the bullet so that it starts right exactly where the launcher is. So that would be player.x, player.y, and then we need to know the angle of the launcher in degrees. And that is actually stored inside of every movie clip as a property called rotation. So we would say player.rotation, and then just kind of end that constructor call there. So we've got a new missile. It's in this variable m. Well, we want to see that on the screen. So we should probably say add child m. That, of course, is going to add our new missile to the display tree. But we want to be able to move our missile. And the way that we are going to do that is by updating the missile object inside of the update function. Well, in order to do that, we have to have a variable that points to the missile. We have to have a variable that points to every missile currently on the screen. So just like we have one variable to store all of our enemies, and that variable is an array, we're going to set up another array to store all of our missiles. So I'm going to say var missiles is a new array. And now what we can do, let's go back down, and we're going to type in the name of the array, and then look for a function to add an object to an array. And in Flash, that function is called push. What we do is we pass in the object we want to add, and that's it. So now what we have to do is write some code in our update function to update these missiles. Now we could go ahead and play our game, just double check, make sure we don't have any compiler errors. And our missiles should be spawning, but they're spawning right on top of the launcher. And they're white and the launcher's white, so we don't see them. We could change the color of the missiles if we wanted to, just to kind of verify that it's working. And there we go. When I hit spacebar, we can see that missiles are spawning right on top of the launcher. I'm going to change my color back to white. And go back to state play and find the update method. That's where our game loop is. And we're going to loop through the missiles array and tell each missile to update. Now you guys should already know how to do this because we've done it a couple weeks now. All we do is exactly the same logic that's in the update enemies function. Okay, we're going to set up a loop, and we can do that with a for loop that loops through every object in the missiles array. Now here we're doing it with the enemies array. Of course, all we would really need to change is this word enemies to the word missiles. So I'm going to go ahead and say, I'm going to call update missiles, and then I'm going to create that function. And let's create a for loop. And as we've discussed in class a couple times, we want our counter variable for that for loop to start at the end of the array and count backwards. And that's just going to save us some weird gameplay glitches. So we're going to say I is missiles.length minus 1. And we're going to run the loop as long as I is greater than or equal to 0. And we're going to subtract 1 from I each iteration through the loop. Now, because each missile is a sprite object, the sprite objects have a function built in called update, which simply moves and rotates them as necessary. So we can start by just saying missiles number I dot update. Now I just saved my file, and I'm going to run it and see what happens. Now, what you should do in this situation is kind of keep pressing the space bar as much as possible and kind of rotate your launcher around to see what the problem is. I think you'll find that the problem here is that the bullets are launching out of the launcher exactly 90 degrees to the right of where they should be. And there's a very good reason for this. In Flash and in most environments, 0 degrees kind of points directly to the right. 0 degrees points exactly to the right. And if our launcher is facing straight up, its rotation value is 0. So if our launcher's rotation value is 0, it's telling those missiles that they should shoot straight out to the right. Now, the solution to this would be to simply subtract 90 degrees from the launcher's rotation value before we create any missiles. So let's scroll down to where we are creating the missiles. Spawn missile. And when we pass in a value for the angle that we want to shoot the missiles in, instead of telling the missiles to shoot in the player's rotation, we're going to tell them to shoot in the player's rotation minus 90. Minus 90 degrees. If we save this and run it, the bullets now come out of the barrel of the gun, which is pretty great. Now, before we start going into gameplay and kind of tweaking what the bullets do and how they work, we need to be aware that we have a memory leak. These missiles are being created, and even though they're going off the screen, they're not disappearing. They're not being removed from memory. So we, of course, do not want that to be the case. We want to be able to remove these from memory. So the way we solve this problem with the enemy class is we said if the enemy class, if its Y position is greater than 425, we're gonna mark it as dead. And y being greater than 425 means it has gone off the bottom of the screen. So we could, in the missile class, we could override its parent class's update method and give it some similar logic. In fact, I'm actually going to pretty much write something very similar. Just go into the enemy class and we can copy this and then paste it into the missile class. So just a recap of what's going on here. We are creating a function called update, but our superclass has a function called update. So we have to use this keyword override to tell Flash that we are intentionally overriding our parent class's update method. So when we tell a missile object to update, it's going to call this function. Now, we still want to use the code that we wrote in the parent class's update method, so we can tell that code to run by calling super.update. Then this says if y is greater than 425, let's mark this missile object as dead by setting dead to true. Now, you'll probably be aware that the missiles will not all go off the bottom of the screen. So this y greater than 425 is not going to work because some of the missiles are moving up. Well, actually, they're all moving up or sideways. So we could say, for example, if y is less than -20, we know it's gone off the top of the screen. We could do similar tests for x. We could say if x is less than -20. We could say if x is greater than 570, and that would work great. However, I'm actually going to add gravity into this system. Once I add gravity into these missiles, they're going to launch up into the air and they're going to fall back down, kind of like mortars. So actually this logic works fine because every single one of those missiles is eventually going to go off the bottom of the screen. So I should not have a memory leak as long as they're all being affected by gravity. So what I want to do now is I want to get gravity working on these missiles. Well, gravity is an acceleration. Well, actually, it's a force that applies an acceleration. And to simulate acceleration, all we have to do is, of course, change our speed values over time. So to get this to work, we are going to, every update, we're going to increase speed y so that speed y becomes a greater and greater value pointing down. This is the simplest way of doing it. We'll just say add 1 to speed y every update. So what that's going to do is, of course, speed y will change. It will point down greater and greater. And I'll just make a note here that this is gravity. By the way, I don't always take the time to write notes, but if you don't know what's going on here, you should probably write notes, a lot of notes, all the time in your code. Let's run the game, hit play, and now when I shoot a missile, it goes up and it falls back down. I like the speed that the missile moves, and I like the this gravity setting right here. Feel free to play around with the gravity settings. So for example, instead of increasing speed y by 1, you could choose to increase speed y by 2, or of course by any other number. If you want to apply some crosswinds, you could of course change the object speed x over time. Okay, this missile class is saved, and it's almost done. I want to point out one thing. When I'm playing the game and I'm shooting the missiles, you'll notice that if you turn rapidly while you're shooting the missiles, they don't exactly come out of the barrel of the gun. And the reason for that is because if your launcher is turning to the side, clockwise or counterclockwise, while it is shooting, the object it is shooting starts in the center of it. So by the time it's moved down the barrel, the angle of the barrel has already changed. So what I want to do is actually spawn the bullets closer, further out near the end of the barrel, not at the center of this launcher object. Again, that sounds like something that should be very easy to do, but we still have to take into account the angle that the barrel is pointing, and this involves trig. Now, luckily, we've already figured out the ratio of the x component and the y component for this particular angle. So all we have to do is add to x and y, speed x and speed y, a certain number of times to simulate a particular number of updates. So if I, for example, want to move the missile down the barrel one update, I would say x plus equal speed x, and y plus equal speed y. And I want you to notice that I'm doing this in the constructor. So as soon as the object is created, we're setting its position, and then we're immediately changing its position before anything is drawn to the screen. Now, we want to figure out how far the object just moved down the barrel. Well, the object, the combination of speed x and speed y, comes out to 20 pixels. So we have moved 20 pixels from the center of the launcher out towards its barrel, but is that enough? How far is that? If you go into the FLA file, you can find the launcher inside of the library, and we kind of want to get an idea of how long that barrel is from the center of the object. You'll notice in the timeline I have a couple layers, and if you hide the layer 1, you'll notice that layer 2 is the barrel from the very center all the way out to the end. So what I want to know is, how large is that rectangle? With it selected, I'm going to go to Properties, and I can see that the height of the rectangle is 57 pixels. So 20 goes into 57 about 3 times. So instead of spawning the bullet right here, if I want to spawn the bullet right at the end of the barrel, I have to move it, I have to update it 3 times before we actually put it on the screen. So if we go back to our code for missiles, I could have these 2 lines of code 3 times. I could put them in a loop that runs 3 times, or I could simply multiply speed x by 3, and I can multiply speed y by 3. Now the effect of multiplying these 2 values by 3 means instead of moving down the barrel 20 pixels, it's moving 60. If we save it and run it, in our game now, the bullets spawn out near the end of the barrel. In fact, I believe what happens is they spawn at the end of the barrel, and then I think their update function gets called before they're drawn, in this case, so that they move out again. It actually makes it look like they're appearing out in front of the object. So I'm going to reduce this back down to 2, save it and run it, and that's a little bit better. Now, it's not a perfect solution. We still have a little bit of a, I don't know, it still looks like the bullets are kind of going not in the same direction as the barrel if you're moving the barrel rapidly like that. And in real life, if the barrel was moving while you were shooting, the bullet would kind of inherit some of that movement, but we're not going to worry about that too much. I think this is fully appropriate for the game we have so far. This missile class is now done. It has all the logic we need for missiles. It has an update method, and it has a constructor which sets up its initial values. So I'm just going to, I don't know why, I have a habit of deleting extra lines that I don't like in my program. I'm going to save it, and what the heck, I'll close it since I'm done with it. I'm done with the title, I'm done with the sprite class, and I'm done with the launcher, and I think I'm done with the enemy. At this point, the only class I have open is the state play class. Our game is interactive at this point because we can spawn objects, and objects are removed, and we can aim them. However, there's no collision detection. So what we want to tell is we want to know whether or not these little bullets are hitting the enemies. There's a couple different ways of doing collision detection. I tend to use the Pythagorean theorem, as you guys saw in class when we created the endless runner style game with the orc jumping over the crates. The Pythagorean theorem works great, and it's actually my preference. I prefer students to use that so that they understand what's actually going on. However, Flash has some built-in methods which does some of the logic for you. Some of it, not all of it. Excuse me. Let's go into state play and find the update method. In the update method, we want to do some collision detection. We need to know, oops, I forgot one thing. Even though we're marking the missiles as dead when they go off the screen, we actually are not removing them. We forgot that step. So just like we have this logic down here to remove enemies, we are going to do the same thing for our missiles array. If missiles number I dot dead is true, then we know it's dead and we need to remove it. We're going to remove it from the display tree with remove child. Oh dear, there we go. And then we're going to remove the missile from the missiles array using array.splice. So we're going to type the name of the array, missiles, type the splice function. We need the index number of the missile we want to remove. We know that missile I is dead if we're inside of this if statement, so we're going to remove missile number I, or we're going to start removing objects from the array at index number I, and we're going to tell it we want to remove one object. And there we go. We can test this by saving it, expanding our screen a little bit, hitting play, and shooting some missiles, and you'll notice that after they go past a certain point on the bottom of the screen, they disappear. Okay, now for collision detection. For collision detection, we're going to check every missile in the scene against every enemy in the scene. So we're going to need to loop through every single missile, missile A, missile B, missile C, and we're going to test missile A against every enemy, enemy 1, 2, and 3. And then we're going to test missile B against every enemy, enemy 1, 2, and 3, and missile C against enemies 1, 2, and 3. What this is this is a loop inside of a loop. We loop through all of the missiles, and then for each missile in that loop, we loop through all of the enemies. In order to optimize the code a little bit so that we're not looping through objects multiple times and slowing down the game, I'm going to actually put my collision detection inside of one of these update methods. And I think I'm going to put it inside of update enemies. And the reason for that is I'm going to check to see if an enemy is colliding, and then if it is, it can be removed inside of update enemies. And then after update enemies is called, update missiles is called. And if I mark a missile as dead inside of update enemies, it can be removed inside of update missiles. I think where you put it is a little arbitrary, but generally you want to update objects first before you do collision detection. So you could put collision detection completely after these two methods, but whatever. So inside of update enemies, I'm going to update, and then I'm going to do collision detection, and then after collision detection is when I check to see if enemies are dead. So what we want is we want a loop inside of this loop, which loops through every single missile. The counter variable I is already taken inside of this loop, so we're going to use counter variable j. And because I'm not going to be removing any missiles in this loop, I don't have to go backwards through this particular loop. So if it's easier, you can just go forwards through it. And I realized I just made a little mistake there. So j is 0. Well, j is less than missiles.length, j++. Okay. Now inside of here is where we do our actual collision detection. This is something that you could refactor as well, but I'll just write the code right in here. Basically, we say if, and then we need an enemy. So I'm going to get enemies number I, and I want to see whether there is a point on the screen that collides with the artwork inside of this enemy number I. So this enemy is a movie clip, and the movie clip class has a couple different hit detection methods, including hit, test, point. And what we pass into this function is we pass a point, and then this function returns true if that point is inside of this enemy's artwork, and it returns false if that point is outside of this enemy's artwork. So the point I'm going to be passing in is the center of the missile, missile.x, missile.y, and I just realized this needs to be missiles number j.x and missiles number j.y. I'm going to end the function call to hit test point. So this if statement reads, if this enemy's i.hit test point, if that returns true, then I'm going to end the if statement and open up a new block of code with a curly brace, and then hit enter, and then it should put in another curly brace for me right here. So if we're inside of this if statement, we know that there was a collision. And then we just simply have to decide what we want to do when there is a collision. Well, I'm going to actually mark the enemy as dead, and I'm going to mark the missiles as dead, or the missile. So enemies number I dot dead equals true, and missiles number I dot dead is true. Now, since I have found an enemy, or excuse me, since I have found a missile that this enemy collides with, I'm not going to continue looping through all of the other missiles. So therefore, I'm going to say break, and the break function is going to stop this particular loop from running. So it won't keep looking for missiles. Okay, so this should work pretty well if we run it and play it. Oh, it looks like I have a runtime error. A term is undefined and has no properties. Update enemies is where that problem is happening. I see the problem. The particular missile that I'm testing in here is not missile number I, it is missile number J. So I need to make sure I write the correct missile there. All right, enemies I, missiles J. All right, collision detection appears to be working. At this point, we want to take our program and really make it a much juicier game to play. And remember, juicy feedback includes things like sound effects and particle systems and screen shake and color and empathy, and there's all kinds of various things that we could add. The two that we'll be focusing on today is sound effects and particle effects. Both are pretty easy to do. So for sound effects, in code, what we need to do is have some sound effects in our library. And you'll notice that in this audio folder, there's a boom sound effect and another sound effect called pew. We will play the pew sound effect when we shoot a bullet, and we'll play the boom sound effect when we hit an enemy. Now, in order for us to spawn new instances of these sound effects at runtime, we have to give them class names, just like we give the artwork. So I'm going to right-click on the boom and go to Properties, and I have to go to the ActionScript tab, Export for ActionScript, and I'm going to call this class Sound Boom. Okay. Couldn't find a class file, that is okay. Right-click on Pew, ActionScript, Export, let's call this Sound Pew, and we say OK. Now, we have given these two assets class names by which we can refer to them and instantiate them in our code. We will not be actually writing any code files for these objects. So I think that makes things pretty simple. Now, if we want to play these, we go over to state play, and right here, we just finished up writing our collision detection. When we collide, we want to play that pew or that boom sound effect. So I can, in my code, instantiate a new sound boom object. I'm going to call this variable SB for sound boom, and its data type is sound boom, and I'm going to set it equal to a new sound boom object by calling the sound boom constructor here. Now, this creates it in memory, but it does not start playing it. If we want to play it, we just say sb.play. That's all there is to it. You can run it and test it. I'll have to pop my headphones in here. Okay. Okay, granted, it is an odd sound effect, but it'll look a lot cooler once we get those particle effects in. Let's get our other sound effect in. The pew sound effect needs to play when we are shooting our bullets. So we need to find where in our code are we shooting bullets. Well, we made that pretty simple. We created a function called spawn missile. So whenever we spawn a missile, we probably want to spawn a sound effect. So we say var sp for sound pew. Doesn't really matter what you call the variable. Its data type is sound pew equals a new sound pew object, and then we're going to call its sp.play method. And again, the reason why we can do this is because when we created that class file on that asset, it gave it a default base class of flash.media.sound. So every sound pew object we create is also a sound object, and that sound class has that play method. So now with those two sound effects in there, you can test it out, make sure it's working. I think that's pretty cool stuff. Okay, well, we now want to add our particle effects. The particle effects are simply going to be lots of little sprites that we spawn on the screen. And in fact, they're going to move as well. So they're going to be subclasses of the sprite class that we wrote. I've got artwork in here. There's a particle artwork for the enemy and a particle artwork for the missile. Let's attach a class file to each of these. So I'm going to right click on particle enemy and choose export for ActionScript. I'm going to call the class particle enemy. I'm using camel case for these, capitalizing P and capitalizing E. Remember, this is a class name, so it should start capitalized. Say OK, OK. Right click on particle missile properties, export for ActionScript. Let's call that one particle missile. Hit OK twice, and then we can right click on either of these and say edit class. So I right clicked on the particle enemy. It created a particle enemy class for us. Let's go ahead and save this before we edit it as particle enemy.as. And let's do the same thing for our other particle class. Right click, properties. Actually, I didn't mean to do properties, but if you do do properties, you can click on this pencil button for the same result. So clicking on this pencil will edit this class right here. Now it created a particle missile class for us. Let's save that as particle missile.as. And now we can start editing these classes. I'm going to work on particle enemy first. Now, particle enemy extends movie clip. I'm going to give these particles a speed x and a speed y, and also a rotational speed so that they can move across the screen. That logic is already built into a class I wrote called sprite, so make this a child class of the sprite class. And now what we have to do is we have to simply set up our starting speed x, speed y, and speed r values. Now I don't want every particle that I spawn to have the same speed x and speed y, or they're going to move in exactly the same way. If I create 20 particles but they're all in the exact same spot, it looks like I only created one particle. So what we need is some random numbers. So if I say speed x, and I want to set it equal to a random number, so I'm going to call math.random. This is of course going to give me a number between 0 and 1, so I have to think about what is the range of possible speeds I want to use here. Now you could just try out some stuff, but let's say I want to speed from -10 to +10. -10 to +10 is a range of 20 numbers, so I'm going to multiply math.random by 20. And my minimum number is -10, so I'm going to say -10, or add -10. And then for speed y, I'm going to give it a similar range of numbers, math.random times 20 minus 10. So that's, if you want to take some notes here, 10 to negative, well, I should probably write that the other way around, -10 to 10. -10 to 10. And let's create a random speed r value so that it's spinning. Math.random. And what the heck, I'll use exactly the same number. Or numbers. In this case, it's saying that we are going to, speed r is how many degrees per update we want to be rotating in. So this means our objects could be rotating -10 degrees per update to +10 degrees per update. And I'm going to want to be able to tell when these particles have died and gone off the screen. But why don't we worry about that later? For now, let's just get these on the screen. So I save this file, and I have to go back to state play. Now in state play, we need a variable to hold our particle objects that we create. Just like we created more than one missile and we created more than one enemy, we're going to create more than one particle, so it makes sense for us to have an array. Now I'm not going to worry about creating one array for enemy particles and one array for missile particles. I'm just going to create an array for particles. Now, if I really wanted to, I could create one array that holds all of my game objects. I could create just an objects array, put all of the enemies in it, put all of the missiles in it, put all the particles in it. The reason why I've created 3 separate arrays is because all of these enemies objects, I have to test for collision against all of these missiles objects. So because these are 2 different collision groups, I put them in 2 different arrays. And this means that we gain some optimization. If every single object was in one array, that array would be very large. It might be 100 objects. And when we try to loop through all of the enemies and see, check for collision detection against all the missiles, that would be not only more complicated to program, but 100 times 100 is a very large number. So we gain some optimization by doing it this way. Okay, we have a variable to hold particles. We now have to create particles, and then we have to update them as well. So I'm going to, I guess I'll create a function to spawn particles. In this case, I'll create a function to spawn enemy particles. So I'm going to say function spawn enemy particles. And you'll want to think, what do I need to know in order to spawn enemy particles? And that's going to make up your parameter list. I suppose if you don't know, the first place to start looking would be to look at our enemy particles constructor to see if it requires anything. So what do we need to know in order to create enemy particles? Well, we don't need to supply the constructor with any information. So what I'm going to do is just say, assume for now there's no parameters here. Let's create a single enemy particle. Var p is an enemy particle object. Let's set it equal to a new enemy particle. And then we have to add that to the display tree. So we say add child p. And then we're going to add it to our particles array. So particles dot push p. Okay. Now, I want you to notice that this spawns only one particle. When we collide with an enemy, let's have the enemy spawn 10 particles. The easiest way to do that would be to take this line of code, these lines of code, and put them in a loop that runs 10 times. So for var I is 0, while I is less than 10, I plus plus. Okay, now of course we have to call this spawn enemy particles from somewhere. Well, we want to spawn these particles when an enemy explodes. So we need to look for our code that runs when an enemy is colliding with a missile. And that code is actually right here when we spawn a new sound boom object. I'm going to call spawn enemy particles from there. And if I hit save and I hit control enter, it looks like I have some compiler errors. Type was not found, or was not a compile time constant, enemy particle. So it's telling me it doesn't know what an enemy particle is. And I believe the reason for that is that I called my class particle enemy, not enemy particle. That seems silly of me. Now I feel I should rename my function. I'll double click on it, copy, and double click paste. Save and run. And what happens when we shoot an enemy? Did you notice anything? Well, we did spawn some particles. They just happen to be up here in the upper left-hand corner. Now we could figure out why, but there's another issue, and that issue is that the particles are not moving. The reason for that is we're not updating them in our update loop. So let's create a method called update particles. And in this loop, we're going to do exactly the same thing we do in our other loops. This update missiles and update enemies. We're going to loop through all of our particles by saying for var I is equal to particles.length minus 1. I is greater than or equal to 0. I minus minus. Okay. The particles themselves, they are subclasses of the sprite class. So they have an update method built in. So all we have to do is say particles number I dot update. Save this and run this. And now shoot yourself an enemy. If you notice, particles are spawning, but they're spawning in the upper left-hand corner. And that's because these movie clips have a default X and Y value of 0. We need to know where to spawn the particles. The particles should spawn where the enemy was. So if you scroll down, or wherever you have your spawn particle enemy function, you'll know now that you need to know where to spawn your particle enemies, your enemy particles. that would be an X and a Y position. So I'm going to pass in X as a number and Y as a number. I made these capitalized so that I don't accidentally confuse them with the lowercase x and y properties that are already part of state play. Okay, so now whenever I call this function, I have to pass in two numbers. And what am I going to do with those numbers? Well, when I create a new particle enemy, I'm going to set its x value to the x value I passed in, and I'll set its y value to the y value I passed in. So when it spawns, that'll be its starting position. Okay, if I try to run this, I'll get a compiler error, and that's because I'm calling this function up here, but I'm not passing in two numbers. The numbers I'm going to pass in need to be an x and a y position of where we want the particles. I want the particles where enemies I just was. So enemies number I dot x, enemies number I dot y. Save it and run it, hit play, and now when you shoot, your enemies throw particles. And that looks all right. There are some changes I want to make to it though. I want the particles to be affected by gravity, so I'm going to go back to the particle class, and I'm going to want to increase speed y over time for each individual particle. So to do that, I have to override the superclass's update method, just like before. Override public function update returns void, and we will be calling super.update because we still want to do the physics that we wrote in there. We're going to be increasing speed y, and it would be a good idea to increase speed y by the same acceleration that you used for your bullets. So for the bullets, I increase speed y by 1, and I'm doing the same thing here for the particles. That should look good. And after doing that, we also need to check to see whether or not these particles have gone off the sides of the screen to determine whether or not we can remove them so that we don't have a memory leak. Well, because I now have gravity, it's now guaranteed that every particle will eventually fall off the bottom of the screen. So I can say if y is greater than 425, dead equals true. Now what we want to do is save, and we want to go back to state play, and we're going to check to see if dead is true. If dead is true, we're going to remove the particle from the game. So if we come back here and we go to our update particles function, we're going to say if particles number I dot dead is true, then we have to remove it. So we are going to say remove child particles number I from the display tree, and then we're going to splice that particle out of the array that is holding it. So particles dot splice from index I one object, and there we go. We should be good. If you run it now, your particles will have some gravity to them. One of the negatives, however, is that the particles, because they have gravity being applied to them, and they have a 50% chance of going up and a 50% chance of going down, more or less, they end up looking like they all kind of shoot down immediately. And so I kind of want to change that spread so that it looks like more particles are shooting up, so that it's a little bit more balanced. So to do that, I go back to my particle class, and I'm going to tweak my speed y starting values so that more of them start by going up, so that fewer of them turn around and start going down quickly because of gravity. So I'm going to keep a range of 20. I want you to remember that up is a negative number. So I want my minimum number to be, say, -15. So my speed y is now between -15 and 5. So if I run it now, hopefully I get a spread of particles that looks a little bit more even, less skewed. It's going to make it look a little bit more like an explosion. Cool. And I think that worked great. Now the last thing I want to do is I want to create particles for the missiles themselves. These ones are going to be a little bit different. I want them to look like a smoke trail, and I don't want them to fall with gravity. If anything, I want them to kind of rise up a little bit and then maybe fade out. So go to your particle missile class, and this also is going to be a child of the sprite class because we're going to give it a speed x and a speed y. And in the constructor, let's set up an initial speed x and a speed y. Well, because I want these to be kind of like a smoke trail, I really don't want them to be moving very much at all. In fact, I don't want them to be moving. I'll give them a speed x of 0. I just won't set that to anything. Maybe for speed y, I'll set speed y to being a random number so that they're not all moving up at the same speed. But if I want all of them to move up, I'm going to give them a range of 2. Now if I don't add a minimum to this, it means my minimum number defaults to 0. So 0 to 1 times 2 is going to be 0 to 2. All right, let's spawn these particles in our game. If you go to state play, think about when do we want to spawn these particles. Well, we want to spawn these particles all the time. So obviously during this update function, but where do we want to spawn the particles? Well, we want to spawn every frame 1 particle per missile on the screen. So with that in mind, it should be obvious that we need to go to the update missiles, and then in the for loop, for each missile on the screen, we're going to make a particle. So what I'm going to do is I'll just create a function for creating these trail particles, and I'll just call that function here add particle missile. And in order to add a missile particle, what is this function going to require? Now I'm doing this backwards. We should probably create the function first. But if you think about it, we need to know an x and a y position of where this particle starts, just like we needed to know an x and a y position for our other particles. So what we could do is we could pass in the current missiles x and y. Missile number I dot x and missile number I dot y. Now with this in mind, let's go create this function and let's make sure that it has 2 parameters being passed in. Oh, I'm sorry, that's missiles I and missiles I. Okay, I'm going to scroll down and I'll create that function. You know what I just realized? I called my old function spawn. I probably want to stick with the same nomenclature. So I'll go back up to where I have add particle missile. I'll call it spawn particle missile. And then I'm going to double click on it and copy so that I don't have to write that out again or remember it. Function paste x, that's not an x, x number, y number, returns void. Okay, well, var p is a particle missile equaling a new particle missile. After creating the particle, let's set its position. So p.x equals that x parameter, and p.y equals the y parameter. Now we have to add this to the display tree so that we can see it. So add child p, and we want to add it to our particles array so that it is updated and then can be removed later. So particles dot push p. Save it and run it. And notice that when you shoot particles, they now have, wow, they now have a bit of a smoke trail. The smoke trail, actually, the particles are still falling, but they're falling slowly instead of rising, and I think that's okay. The particles need to fade out and they need to disappear, obviously. So I'm going to go back to my particle missile class, and I'm going to override its superclass's update method. So override function, actually override public function, update returns void. We are going to say super.update, and then let's think about what we want to do here. Well, as I mentioned before, we want our particle to be fading out. Remember that the movie clips inside of Flash, they have a property called alpha, which controls its alpha value. Alpha is a property is a number between 0 and 1, with 1 being opaque and 0 being transparent. So I'm going to say every frame that this object is on the screen, let us reduce its alpha by 5%, 0.05. When is this object then dead? Well, this object should be removed from the game once it's invisible. So we're going to say if alpha is ever less than or equal to 0, we'll set dead equal to true. And then go ahead and make sure you save it. We've already written the code. Since this particular particle is going into the particles array, we've already written the logic for the particles array to remove dead particles. So we should be all set to run it. Hit play, and now when you shoot these particles, they fade out. Looks okay. It could be better. It's a little weird, and the reason why it's weird is because the smoke trail, those little particles, they're the same size as the bullet itself. So to make it look a little less weird, I'm going to make these particles smaller. And in fact, I'm going to give them slightly random sizes. So to change an object's size, we're actually going to change its scale. There's a property called scale x and scale y. If we want to scale proportionally, we want to make sure scale x and scale y are the same value. So I'm going to be setting scale x to something random, and then I'm going to set scale y equal to whatever I just calculated for scale x, so that they scale proportionally. Now this is going to give me a number between 0 and 1. Now 0 is, well, it's infinitely small, we won't see it. And 1 is this, as we just determined, is the same size as the missile itself, which is not what I want. So instead I'm going to try 0.1 to, let's say, 0.6. That is a range of 0.5 with a minimum of 0.1. Save it and run it. And now you find that the particles emitted by the missile, I think, are much more visually interesting. They're more interesting while simultaneously being less distracting. Okay, well, I think there's one more thing we have to do to make this a game, and that is we have to have a win state or a lose state. So I'm going to make it so that if any enemy goes off the bottom of the screen, then the player loses. So to do that, I'm going to go out to state play. We are always updating the enemies in the update enemies function. We can at any time look at any enemy's Y position to see if Y is greater than 400. Now the enemies, they pop off the screen when they're marked as dead. But when they're marked as dead, we could take an extra step to see what their position is. And if enemies number I, if its y value is greater than or equal to 425, which, by the way, should be the exact same number we used in the enemy class, then we have a game over situation. Now, I'm not going to write all the code for game over right here. I'm going to refactor that into a different function. So game over. Let's go write the game over function. Doesn't really matter where. Create a function in state play called game over. And when we get a game over, we have to think about the things that we want to do. Now, obviously, we want the player to go in our main timeline. We want them to go from frame 2, which is where the gameplay is happening, to frame 3, which says game over. So we know at some point we're going to want to access the root and say go to and stop frame 3. Now, root is not a movie clip, so we're just going to cast it as 1. Well, the variable root is not a movie clip. The object that it stores is, which is why we can do the cast. Okay, we want to make sure we don't have any memory leaks. So really, we have to make sure that everything that we've added gets removed from the display tree, but also the event listeners and any variables. Well, this object is a class, so it is entirely encapsulated. So any variables created in here should be okay. What we have to do is we have to make sure that this state play object and anything inside of it is removed from the display tree. Well, in my main timeline, I think I'm adding additional layers here. Hold on. There we go. Our state play object is this little white dot right here, and it only exists on frame 2. And just due to the way that the timeline works in Flash, if it's on frame 2 and it's not on frame 3, that means between frame 2 and frame 3, remove child is being called on that object. So that object is being removed. And the cool thing is, because the display tree has objects inside of objects in Flash, anything inside of this object will no longer be in the display tree when we get to frame 3. So that part is taken care of. The next concern is that we remove any event listeners inside of state play. Now, I was careful not to add any event listeners to enemies or missiles or particles or the player launcher. So the only event listeners are these 3 right here. So I'm going to copy these 3 lines of code, and I'm going to go down to where I call game over, and I'm going to paste those in there. And it's important that we change the add event listener to a remove event listener. Save it and run it. And if you allow yourself to get a game over, there you go. It should work. If you do everything correctly, you shouldn't get any runtime errors. And of course, you shouldn't get any compiler errors either. Well, that is everything I wanted to show you. Obviously, you could make this a much more interesting game by adding a user interface, by playing around with color and depth and more sound effects, screen shake. There's all kinds of different directions you could take it in. I hope this was a helpful lesson. If you have any questions, of course, please get in touch with me and let me know.